Hello, today we started a new unit, Unit 8. The first day is going to be Pascal's triangle and the binomial theorem. So Pascal's triangle is a special pattern in a triangular arrangement where the first number in each row is 1, the last number in each row is 1, and we get all these numbers in the middle by adding up the two numbers above it diagonally. So we start off with row 0, and it does start with row 0. I'll tell you why in a minute. Row 1 is 1, 1. Row 2 will be 1, 2, 1. Row 3 would be 1, 3, 3, 1. Row 4 would be 1, 4, 6, 4, 1. And row 5 was 1, 5, 10, 10, 5, 1. How do I get all those numbers in between? I add up the two numbers above it diagonally, like this, and so on and so forth. Well, are there any special patterns? Well, let's see. How many terms are in row 3? When I look at row 3, I see 4 terms. Row 4, I see 5 terms. So if I hit, just call it in general, row n, n plus 1 terms. As you can see, I put down, so like row 5 would have 6 terms and so on and so forth. Is there another pattern? What is the second term in each row? What is the second last term in each row? Well, if you look at row 5, the second term is 5, the second last term is 5. So the second term equals the second last term is equal to the row number, which we're just calling n. Do we see any symmetry in this table? Well, if you go right down the middle of this table, there's symmetry down the middle. Once you get halfway, the numbers repeat in reverse order. Nice little pattern that we're going to get. And finally, what is the sum of each row? Well, if I look at each row, well, row 0, the sum is 1. In row 1, the sum of those terms is 2. And then I get 4, 8, 16, 32. Are we seeing a pattern here? Absolutely, we're seeing a pattern here. Each sum is 2 to the n for row n. This is 2 to the 0. This is why it's called row 0. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. So is it a pattern? Yeah. The sum is equal to 2 raised to the n for row n. And what I just boxed here in red is a short little video on how Pascal's triangle is, the pattern is created. They show you some of the other special patterns that happen in the triangle. You should watch it. I think it's not more than 2 minutes long. So please click on this or type it into your computer and watch this video. So the question is there a way to determine Pascal's triangle by using the calculator? And the answer is yes. It comes from what we did in Unit 6, that special combination key, that NCR key that's on the calculator. I'm going to show you an example in a second and where it's at, but if you recall, use a special math key, you move it to the probability menu, and you choose number 3, and you get the NCR key, and if you have an older calculator, you got to type in the number for n before you hit the NCR key. I'm going to go through if I can do this in a second. So here I am on the calculator. So if I don't want to do 5C2, which I said the answer is 10, I would go hit the math key. I would move it over to the probability menu. I would hit the NCR key, which is number 3. I get these little shadow boxes, so I just have to do 5, 2, I got 10. If you have an older calculator, you got to hit the number 5 first, and then hit the math key, move it over to the probability menu, pick the NCR key at number 3, and then just put in the 2, and you still get 10. I'm going to show you how I can do this for many, even the whole row. Okay. So Pascal's triangle, which is over here, the 1, 1, 1, 1, 2, 1, and so on and so forth, is really built in this combination pyramid, or triangle. The top row is 0, so 0 sees 0. If you have 0 items and you want to choose 0 of them, there's only one way to do that. If you have 1 item and you want to select none of them, there's only one way to do that. If you have 1 item and want to select one of them, there's only one way to do that. And you get this special pattern. 2C0 is 2, 2C1 is 1, excuse me, I'm doing it backwards. 2C1, 2C0 is 1, 2C1 is 2, 2C2 is 1, and so on and so forth. I'm going to show you how to put this one into the calculator. So I'm showing you how to calculate the 4th row of Pascal's triangle. So I'm going to type in 4C0, 4C1, 4C2. Well, I already did 4C0. 4C1 is going to bring this over. And I can do it over and over. And I could calculate them all out individually. I think this seems like a pain to do, so maybe there's a better way. Instead of doing them all individually, look at that. There's my Pascal's triangle. The one got taken off, but it's 1, 4, 6, 4, 1. And you saw in the calculator I was able to get all 5 numbers in row 4 by typing them in. But there is a better way. I'm not going to do it that way ever again. That's way too much work. I will say this about Pascal's triangle. I do notice the symmetry again. And the whole idea is that the first term and the last term are 1 because I start off with NC0 and I end with NCN, and they both equal 1. And the second term is NC1, and the last term is NCN minus 1, and that's always the row number n, and so on and so forth. Now I'm going to show you how I can do a whole row in Pascal's triangle all in one step in the calculator by using some special keys. I'm going to have to use the curly brackets, which are above the parentheses, and the comma key, which is above the number 7, and I'm going to be able to do this whole thing in the calculator and get this result. Okay, I'm going to do the 5th row of Pascal's triangle by doing 5C, curly brackets, 0 through 5. You must start with 0. So 5, that special math key, NCR, I'm going to do curly brackets, so second, parentheses, not parentheses, 0, commas above the 7, 1, comma, 2, comma, 3, comma, 4, comma, 5. Make sure you put the commas, and don't do double commas. You don't need to end it with the closed parentheses, it doesn't really matter. It will work without it, and I hit enter, and there you go. If you notice, 1, 5, 10, 10, 5, 1, and exactly what the calculator says. Hopefully you notice the symmetry. Once you get halfway, the numbers just repeat in reverse order. So once you get to 1, 5, 10, you see the 10 comes up again, you know it's going to go 10, 5, 1. You could do any one you want. Let's say I wanted to do the 8th row. 8. Well, obviously I have to go beyond this. So I got to do comma, I can grab that 6, comma, 7, comma, 8. Hit enter. There is the 8th row. 1, 8, 28, 56, 70, 56, 28, 8, 1. If you do a row that is longer than your screen, just use your arrows to scroll left or right to see the whole screen. Okay, here's another video to watch if you want. It's a little bit longer. It shows you how it uses the NCR key to calculate all Pascal's triangle and the relationship. It doesn't use that notation NCR. It uses this whole parentheses N over R notation. It means the same thing. Okay, so what are we going to use it for? Well, we're going to use it to expand things. So what we can do, let's talk about expanding. What is x plus 1 to the 0? Well, that's just the number 1. What is x plus 1 to the first? Well, that is 1x to the first plus 1y to the first, if you write it out very formally. And x plus y squared, hopefully you remember, it's going to be 1x squared plus 2x to the first, y to the first, plus 1y squared, again, when you write it very formally. So what am I seeing here? I'm seeing a pattern. Let's look at the coefficients. 1, 1, 1, 1, 2, 1. These coefficients are just Pascal's triangle. That's all it is. This is row 0 because that was raised to the 0. This is row 1 because that was raised to the first. This is row 2 because it was raised to the second. And so on and so forth. So we're going to use Pascal's triangle to take these binomials, x plus y is a binomial, 2 terms, raised to an exponent, to the 5th, to the 10th, to whatever we would need to do. So what we're going to do is take x plus y raised to some power n, 3rd to the 5th to the 10th, whatever you want, and here's a pattern. It's always going to start off with x to the nth power, whatever n is. I have to know what that n is. And then it's always going to end with y to the n. Again, whatever n is. And then all the terms in the middle are going to be created. My exponent at the variable x will go down by 1, and my exponent on the y will go up by 1, and I will need the coefficients from Pascal's triangle. That's what I'm going to use. Those coefficients, even the first one and the last one, are coming from Pascal's triangles. It's just that the first coefficient and last coefficient are 1. Just like the first term and last term in Pascal's triangle is equal to 1. So here's the binomial theorem, very formally written out. I'm never going to use it that way. What I need to know the nth row. That is the key. So here I go. X plus y to the 3rd. I can multiply that out and do x plus y times x plus y times x by y and expand it out and do this and that. It takes too long. Pascal's triangle. My 3rd row of Pascal's triangle is 1, 3, 3, 1. If you don't know it by heart, just type it in the calculator like this, and it'll give you the row. And that means I start off with the number 1, 1, x to the n, which is 3, y to the 0, I'm not going to write that, plus my next coefficient, 3, my x now becomes x squared because it goes down by 1, and the y that was originally y to the 0 goes up by 1, becomes y to the 1st. Then I do plus another 3, that's the next coefficient. X becomes x to the 1st, y now becomes y squared, and then finally plus 1y to the 3rd because x goes away. Now, I don't write out all the 1s when I'm really done. I just get x cubed plus 3x squared y plus 3xy squared plus y cubed. That is x plus y to the 3rd power. Okay, let's look at this result of x cubed plus 3x squared plus 3xy squared plus y to the 3rd. A couple things I noted off to the right. The coefficients come from Pascal's triangle. The exponents on x go down 1 each term. The exponents on y go up 1 on each term. And here's what I forgot to mention. The sum of the exponents in each term is equal to the n. In this case, 3. This exponent here was 3. The sum here is 3. The sum here is 3. And the sum here is 3. And then finally, the number of terms I should have should be 1 more than the row number that I did. So I did row 3. I better have 4 terms, or n plus 1. So here I go with a plus b to the 6. So instead of x and y, I'm going to use a and b. I need the 6th row. Put the 6th row on the bottom. I don't know that by heart. I just do 6, c, 0, 1, 2, 3, 4, 5, 6 in the calculator, and it gives me my 6th row. I'm going to need space here. A lot of terms here. 6th row means 7 terms. 1, a to the 6, plus 6. A to the 5th goes down by 1. B to the 1st goes up by 1. Plus 15. A to the 4th. B squared. Plus 20. A cubed. B cubed. Oh, I think I'm in the middle. Same exponent. Plus symmetry. 15. A squared. B to the 4th. Plus 6. A B to the 5th. Plus 1. B to the 6th. I should have 7 terms there, and I do. The sum of the exponents of each term better be 6. 6, 5 plus 1, 6, 4 plus 2, 6, 3 plus 3, 6, so on and so forth. That's how this works. Okay, a plus b to the 5th. 5th row, 1, 5, 10, 10, 5, 1, 6 terms. I use those coefficients, and I created a plus b to the 5th by using my Pascal's triangle, doing my exponents. So how about a minus b to the 5th? How is this minus sign going to be different? How's it different? Well, this is all it does. It alternates plus and minus sign. First term is positive. And really what I'm doing here is that I'm using a negative b instead of b. That means any b that has an odd exponent should have a negative sign with it. So this one I did above, I'm going to do exactly the same thing, except I'm going to go every other term. I'm going to go positive, negative, starting with the first term, a to the 5th being positive, not the second term. Use purple. So this turns out to be a to the 5th. Now minus a 5a4b plus 10a cubed b squared minus 10a squared b 3 plus 5a b4 minus b to the 5th. And again, every term that has an odd exponent on b had a negative sign in front of it. That's what we're doing. Well, how about x plus 2 to the 5th? Well, x plus 2 to the 5th is very similar to a plus b to the 5th. So I'm going to take that a plus b to the 5th that I did in blue. I'm going to rewrite it down below. But instead, every time I see a, I'm going to put the letter x. And every time I see b, I'm going to put it in the number 2. I'm probably going to use parentheses around it. And then I'm going to simplify it. So all I did was rewrite this problem and get rid of all the a's and b's and put in the x's and the 2's for all the a's and b's, and I use parentheses. Now I'm just going to simplify it. For me, this, I do each term by itself, and if I have to, I use my calculator. This becomes x to the 5th plus 5 times x to the 4th times 2 plus 10 times x cubed times 4 plus 10 times x squared times 8 plus 5 times x times 16 plus 32, and when I'm done, I get x to the 5th plus, well, 5 times 2 is 10, x to the 4th plus 10 times 4 is 40, x to the 3rd plus 10 times 8 is 80, x squared plus 5 times 16 is 80x plus 32. That's what it turns out to be. Not that hard. just do one little term at a time, substitute things in, and if you got to use your calculator to do the arithmetic, use your calculator. Here are a couple videos that give examples of the binomial theorem. They're not too bad. Okay, x squared plus 2 raised to the third. I'm just going to do a plus b to the third. And that's just going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. And then I'm going to substitute in my a's and b's. And I did that with parentheses. I cleaned it up each term one by one. I multiply it out, and I get my final result of x to the 6 plus 6x to the 4th plus 12x squared plus 8. How about when I put this minus sign here? Oh, all it does is alternate positive and negative. That's all it does. Don't have to do anything special. Rewrite this. X to the 6 minus 6x to the 4th plus 12x squared minus 8. There we go. I just went positive, negative, positive, negative. So as you can see for this example, 2x plus 3 to the 4th. I used the 4th row of Pascal's triangle, 1, 4, 6, 4, 1. I wrote it out with a's and b's. I substituted in 2x for a and 3 for b. I did all my little arithmetic, expanded it out, multiplied it out, and I got that final result there on the bottom. Now I do a little step at a time. This one took 4 steps. And then finally this last problem, it's a lot of work. 3x minus 2y to the 5th. I used my 5th row. I alternated signs between positive and negative because of the minus sign in the middle. And I put in 3x for a and 2y for b. I did one little step of substituting it in. I kind of did the arithmetic of breaking it down in the middle. And the last step, I just multiplied everything out, used my calculator. And I got the final result there on the bottom.